Working in chapter 15, we're going to operate on polynomials. The first example is to subtract one polynomial from the other. Students misread this problem. It says subtract this polynomial from this polynomial, which translates to writing this polynomial first, 2t cubed minus 13t squared plus 3 minus the first polynomial, which is t cubed minus 6. The way we do subtraction is we change subtraction to addition if we take the opposite of what follows. So t cubed becomes negative t cubed, minus 6 becomes plus 6. We now would like to add. I like to underline like terms. So I'm underlining the t cubed terms. So that total is just t cubed. The t squares, I put a double underline, so it's just negative 13t squared. And the constants, I triple underline, so it's plus 3 and a plus 6 for a plus 9 answer. That helps me organize my thinking, don't get confused. Okay, let's multiply some binomials. Here we have the situation where we have two binomials. And the process that I'm going to use is called FOIL, first, outer, inner, last. So let's multiply the first terms together, which is 5r times r, the outside terms together, which is 5r times 3, the inside pair of terms together, which is minus 1 times r, and the last terms minus 1 times plus 3, which is all written below. Doing the calculation, we have 5r squared plus 15r minus 3. Combining some like terms, we end up with an answer of 5r squared plus 14r minus 3. The next problem is a multiplication of a binomial and a trinomial, or polynomial multiplication. We like to use the distributive property of multiplication. So we're going to take the x from the binomial and multiply it times all three terms of the trinomial. Then we take minus 2 from the binomial times all three terms of the trinomial. Further distribution, we get x cubed minus 7x squared plus 4x minus 2x squared plus 14x minus 8. X cubed is all by itself, so I write that down. I underline the x squared terms with a single underline, so that gives me a total of negative 9x squared. I double underline the x terms, so we have 4x and 14x, which is 18x. And finally, we have the constant minus 8. The next problem is to square a binomial. Many students do this problem. We've got to be careful. Squaring a binomial is not the same as squaring a monomial. Squaring means to repeat as a product. So since we have a binomial and it's squared, we repeat it as a product. Now we use FOIL. So the first term is 81x squared. The outer pair is 63x. The inner pair is also 63x. And the last terms multiplied is 49. When we combine like terms, we get 81x squared plus 126x plus 49. Here we're dividing two polynomials, a trinomial and a binomial. It's not a monomial, which is done a little bit easier. It's a long division process. Long division, just like in arithmetic, we put the denominator 2y plus 1 on the left. The numerator, we put underneath a division symbol on the right. And we do a trial division. How many times does 2y divided into 14y squared? It goes in 7y times. you want to line up like quantity. So I put the 7y over here under this. Now the next step in a long division is take the quotient value 7y times the divisor, which gives me 14y squared plus 7y. In a division, we now want to subtract. Subtracting is adding the opposite. So if I take the opposite here and add, this cancels. Take the opposite here and add, it gives me 12y. We're not done because there's something else to bring down, the plus 6. We start this process all over again by dividing 2y into 12y to get a sample quotient. That's going to be plus 6. Put it here. Take this new quotient times the divisor. 6 times 2y is 12y. 6 times 1 is plus 6. We would like to subtract. That's done by adding the opposite. The opposite of both these terms becomes negative 12y and a negative 6. When added to the above, it cancels, giving me a remainder of 0. So in this particular problem, there is no remainder. The answer to this long division is just the quotient 7y plus 6.